So in this problem, you got 18.0375 for X1. And what about you, Sonica? What'd you get? You can put it in chat. Okay, so Sonica got a different number. And
ooh, okay. I may have done something wrong then.
Maybe. And so what about you, Daniel? Did you get your X1? Sonica got 12. Oh, you don't have an answer? Okay. And what about Steven? Okay, 2.58. Well, so remember we have this technique, and I don't know if you did this, and so I'll write it here. Remember that in order to find the optimal consumption bundle in either of these cases, we have to solve the consumer's utility maximization problem. And that involves what we called this tangency condition and then the budget condition. So, Diego, do you have the tangency condition?
I don't define. I'm not sure about the tangency condition. Like when you're mentioning it to me by term.
Yeah. Well, I'll tell you something. That's where we have MRS is equal to PX over PY.
And that's the X is taken from the utility function, right?
You mean this little x?
Yeah, right?
No. Well, this is just the price of X.
Oh, so, never mind. Yeah, I got you.
Yeah. So you didn't do anything like this, right? If you don't have an equation like this, then you didn't do it.
Yeah, perhaps. Yeah.
Well, I want to point something out to you. I'm not saying your answer is necessarily wrong, but you might have done with the Cobb-Douglas because it's mathematically so simple. There are some shortcuts that people sometimes use, but I want to point out to you that this solution that we've been working on, it's recorded in the other videos, and you know, is the way to actually solve these consumer optimization problems or these utility maximization problems. It's required. So this is the one place in this class in particular where you can kind of blow up, because if you get it, this isn't, and it's never about just getting the right answer. It's about learning the techniques to get the right answer. And so, like, for example, if you do a shortcut technique and you get the quote, right answer on Ignithium, but you don't show your work with the tangency and the budget conditions being solved, then when I go over the exam at the end, I won't give you any points. Yeah. So be careful if you see like a shortcut method that doesn't, illustrate, okay, what's the tangency condition and what's the budget condition. So I'll go to Sonica now. Sonica, are you there?
Yeah.
Did you do a tangency condition and a budget condition?
I'm just guessing here. I think the tangency condition is 37 divided by 100, but I'm not sure
No,
anymore.
no. It's not. And what about you, Daniel? You put yours out. Are you there?
No.
Do you have a
Honestly, I just have a graphing calculator here, plugging in random numbers and hope it's spitting out the right run.
Well, okay. Just remember, you need to be able to document your tangency condition and your budget condition. So be careful. Okay. So what? Remember the tangency condition for the Cobb Douglas is AY over or alpha Y over beta X is equal to PX over PY. So in our case, in this particular problem, right? So are you there, Stephen? Did you come up with something?
No.
No. Okay. So I'll go back to Sonica really quickly. You there?
Yeah.
Do you know what A stands for? It's the tacos parameter, right? Alpha.
Yeah, it's 37 over 100.
Right,
And
which
then
we would write that as 0.37
0.37.
y divided
Yeah.
by
Beta would be 0.63.
yeah 0.
Yeah.
0.63 0.63 x is equal, and what's the price of x?
Price of X is 13.
Yeah, so 13 over the
Divided
price
by 12.
14, right?
I thought it was 12.
Was it? We'll go back
I
and
think
look.
so.
Oh yeah,
Yeah,
it's 12. It's
I
12.
wrote it down.
Yeah, it's 12. So this is our first equation, right?
I
Yeah.
did it backwards. That's what I had wrong. That's why my numbers are off.
Oh, okay. Well,
I put
okay.
yeah, I put 0.63 on the y instead of the x. So that's why my numbers came off all wrong.
Yeah, well, okay. But it's important to know that this is our tangency condition, and to get it, I mean, like your first line on your solution should have the tangency condition, and I would write it out like that, and then maybe you could skip to this,
Mm-hmm.
and then the next one is the budget, and you can tell me the budget, Diego, if you want to.
The budget?
Yeah.
Oh, it's 195, right?
Yeah, so 195, because this is our second equation. Hopefully you remember this is, income or budget px times x plus py times y. Okay.
Mm-hmm.
So in this case, our income, you said, is 195.
Mm-hmm.
And then our price of X is what? The price of tacos. You gonna tell me?
For what?
For our problem. We have to, I'm just filling in this, right?
Oh, yeah, x equals 9.45.
Well, no. Okay,
Oh.
you're kind of skipping ahead.
Oh,
you see
my
this
bad.
equation right here? I
Yeah.
is 195. PX is
13x plus 12y.
Yeah, okay.
Equals
Okay.
195?
Yeah. Okay.
Okay.
Yeah, now you're talking about language. So
my bad. I thought that was already kind of,
Well, no, but see, the thing is, it's like, and so, do you agree with this, Sonica? Did we do it right?
Yeah.
Okay. So these two equations, the ones I'm pointing to right here, these are essential. These are like, like I told you guys before, it's like supply and demand. So if you don't write your two equations that you're solving to find X and Y, then it's, you can't properly illustrate the solution. Okay. So that's what I'm trying to get at, Diego, why I was like, oh, you're like moving too fast. You know what I mean? And I
Yeah, I
don't know if
gotcha.
in your work, if you have these two or not. You said the one was backward and that, that's what it is, whatever. But you
Mhm.
need two equations. And then, the technique that we talked about is you'll solve one equation and substitute it into the other one, right? And then you use that technique to solve for X and Y. Okay?
Mhm.
Okay. So I'll open it up. Did anybody do this way? Because if you didn't, this is what you got to do. Okay. All right. So I guess we'll go ahead and leave it there because it's 8:30 right now, and I'll get back with you guys at 8:45, and we could talk about this just for a little bit more, but then we have to move on to the rest of the material that we want to cover for this lecture. Okay, so I'm going to go ahead and mute. Okay, I'm back. So I want to show you all something else really quickly first. So are you with me, Sonica? Can you hear me?
I can hear you.
Okay. So, and I don't know if anybody else has any questions about what's being done here, but it's kind of a good idea to bring this example full circle. So I'm going to stop sharing for a minute and then share this screen from Ignithium. And this is by way, to help you all practice. So this is the problem we were working on, number 16. And let's take a look at the answer. So 12.49. Okay. Are you with me, Sonica?
Yes.
Okay. So let's look up at question 14. So question 14, it has the same numbers, right, as question 16. But it says, how many tacos does he purchase before the price change? So this was our X0, and we have 5.55. Do you see what I mean, Sonica?
Yeah.
And then question 15 says, how many tacos does he purchase, right, after the price change? So this is with the price going down to 4, which should be more, and it's 18.04. Right.
Okay, so I'm on the right track, which is good.
Okay, that's good. So, but if you take the 18.04, and I'm going to do it on my calculator right here. So I have my calculator out, and I'm putting in 18.04 minus the 5.55, and sure enough, I get 12.49.
Okay.
So the decrease in the price from 13 to 14, this is what it's asking about, right? The price change, which is a decrease in price in this case, caused the consumer to purchase 12.49 more units of the good, right? So that was the effect of the price change on the consumption of tacos. Does that make sense, Diego?
Yeah, it makes sense.
Yeah. So these two questions, 14 and 15, are related to question 16. And then we move on to question 17, 18, 19, and 20. So this homework I'm going to put up is going to be due next Tuesday. And the remaining of, questions on the homework are something we're going to talk about in today's lecture. And then hopefully with that, you all will be able to answer the question. So, or the remaining questions. So